Okay, good afternoon. So we're going to look at flowchart proofs today. So hopefully between the table proofs or the flowchart proofs, one of them will make sense. So let's start by marking up our picture like we always do. So DB bisects AC. So we know that these are the same. And then we have DA is congruent to DC. So we can also mark this. And then by the reflexive property, we know that DB is congruent to DB. So this is going to be side, side, side. Okay? That's what we're going to use. So then, remember you always start with your given. So we're going to do DB bisects AC. And then DA is congruent to DC. And this is our given. Okay? So then the next step is B is the midpoint of AC. Okay? And that is definition of segment bisector. Okay, so then we have that. So then let's go based off of our midpoint. So what do we know about midpoint? Then we know that AB is congruent to BC by definition of midpoint. Okay, so now we have two of our sides, so we need to state our third side. So we have DB is congruent to DB, and that is by the reflexive property. So then now we have DA is congruent to DC, so that's one side. We have AB is congruent to BC, so there's another side, and then we have DB is congruent to DB, so there's our third side. So now we are able to say that triangle ADB is congruent to triangle CDB. This is by side, 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 congruence, postulate. Okay? Alright, so now that we've done this, let's look at what it would look like if we put it into this flow chart. Okay? So, like always, we start with our given. So that's what we're going to put here. So we're going to do DB bisects AC. And under it, we just write given, because that's what it is. Okay, so then our next step, we said B is the midpoint. So we're going to state that. B is the midpoint of AC. Okay? So this is definition of segment bisector. Alright, so then from here, well, if we have the midpoint, then we know that AB is congruent to BC. And this is definition of midpoint. Okay? Alright, so then what else do we have? Well, we could say that DA is congruent to DC, and this was given. And then here we can say DB is congruent to DB, and this is reflexive. So now do you see that we have all three aspects, all three parts that we need, and so they all come together. So now we have that the triangles are congruent by side, 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 congruence, postulate. Okay? So I'm going to give you a second to finish copying that down. Alright, so then let's look at the next one. So this time we're just going to jump straight in. And let's see if I can get this to good times. Okay, so first we mark up our papers, or our drawing. So PQ is parallel to SR. PQ is parallel to SR. And then we have PS is parallel to QR. Okay, so then we're going to take what we know about parallel lines and their angle relationships to form our picture. So we have alternate interior angles. Okay? And then we have the reflexive property. So we have an angle, side, angle. Remember, your angle is or your side is included. So it's going to go in the middle. So then we get started. So we're going to start with our givens here because those are going to lead us to our parts that we have. So we have PQ is parallel to SR, and this was given. And then we have PS is parallel to QR, and this is given. Okay? So then, from here, let's look at the angles that we were given. So because PQ is parallel to SR, we know that angle QPR is congruent to angle SRP. And this is by the alternate interior angle theorem. Okay, so then we know PS is parallel to QR, so we know that angle RPS is congruent to angle PRQ. And this is from the alternate interior angles theorem also. Okay? And then the last thing we need to state, we have our angle, let's state our side. So we could say PR is congruent to PR, and this is by the reflexive property. Okay? So then, now we have all three aspects that we need. So now we can state that our triangle is congruent. So we have PQR is congruent to triangle RSP, and this is by the angle side angle congruence postulate. But are we done? I really highly doubt that everyone answered. So are we done? No, because if you look, it said PS is congruent to RQ. Well, so far we just have that our triangles are congruent. So this is where that CPCTC is going to come in. So now that we have that our triangles are congruent, we can now say that their parts are congruent. So now we have CPCTC. Okay? All right. Let's do this one together. Okay? So we have M is the midpoint of BD. So here's BD, so M is the midpoint, so we know that these are going to be equal, and then M is the midpoint of AC, so then we know that these will be equal. And we have to prove that AB is parallel to DC. Well, that should be pretty easy. And then we can, by vertical angles, say that those angles are congruent. So then what are we going to use? What? Side, angle, side. Okay? So let's start with our givens. So we have M is the midpoint of BD given. And we could just follow that right away. So if we know M is the midpoint, then we know that BM is congruent to MD, right? And that is just from definition of midpoint. Okay? Alright, so then we have M is the midpoint of AC, and that is also given. Okay? Alright, so then we have AM is congruent to MC, and this would be from definition of a midpoint. Okay? So while you're writing down, I'm just going to explain this. If you look, it's very logical. We give our givens, and then because we have this given, okay, well, what do we know? Well, we know that BM is going to be congruent to MD. If M is the midpoint of AC, then we know that AM is congruent to MC. Okay? And then the last thing that we can state is that AMB is congruent to angle DMC by the vertical angle theorem. Okay? Alright, so we have our three components. So now we can say that our triangles are congruent. And this is by side angle side congruence postulate. Okay? Alright, so then, alright, well, we're trying to say that they are parallel. Okay, so when we think back to those theorems that we learned, if we said that two angles were congruent, then we could prove that lines are parallel through a converse, right? So if we say that angle MCD, so this one right here, is congruent to angle BAM, oh, MCD is right here. Okay, so yeah, this makes more sense. Okay, so then this, we know that they're congruent by PCTC. And then we can now say that AB is parallel to DC by converse of alternate interior angles theorem. Okay? Okay, so what I want you to do now is you are going to try with your group this number 4 and number 5, okay? And then I will schedule for 4 and 5 to be posted through Remind so that you can check them this evening. And then if you finish both of those proofs, then you need to get started on your homework, which you should have picked up when you walked in, this lesson 12.1 homework, okay? And so it's just 4 questions, and that needs to be done also. And then if y'all have any questions, just come on in Wednesday or Thursday, and we'll get this all figured out, okay? All right, I expect you to be working and on your best behavior. Act as if I was there, but to be better. All right, have a good day.